Hello everyone, and thank you for joining this webinar, held as part of that proactive educational series. I'm Gustav Georgievski, the manager of the Building Inspection Services team within the Audits and Inspections Division, and will be the host today. Welcome to our BBA webinar on the Building Proactive Inspections Program and common non-compliances the team identify. We are running a hybrid webinar today that includes live streaming of learning content with interactive polls and live Q&As answered by our fantastic team. I encourage you all to please type your questions into the Q&A chat function during the live streaming, and also to participate in the interactive polls. So please enjoy. I would like to begin by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders peoples attending the session today. Today you will hear from Nathan Naidu. Nathan is a team leader within the Building Inspection Services and has been with the VBA for just over 2 years. Prior to this, Nathan has over 10 years experience in the private building surveying sector as a building inspector conducting mandatory inspections and as an assistant building surveyor. Nathan will touch on the proactive building inspections program, what we are out to achieve, and how we risk rate non-compliance that we have identified on site. As Victoria's building and plumbing regulator, the VBA is committed to ensuring a confident and thriving industry and calibrates with stakeholders to enhance practitioner competencies and deliver improved outcomes for the community. We have a role in ensuring practitioners understand how to do things correctly and in discouraging risky, harmful or illegal behaviour in the building and plumbing industries. In today's webinar, Nathan will show you examples of the common non-compliances the team identifies on a daily basis, in the hope we all work collectively to improve building construction standards to safeguard the end consumers. Now, before we begin, I'd like to let you know that this session is being recorded and the link to this presentation will be made available on the VBA website along with our previous webinars. If time permits, we will be answering some pre-submitted questions during the Q&A session at the end of the webinar. Please still submit your questions via the Q&A chat function during the webinar, as the technical team will still be available to answer your questions in the chat room. At the end of the webinar, we'll collate all the unanswered questions and we'll provide an answer to as many as possible. A copy of the Q&A will be sent out in the following weeks. Also, during the webinar, we'll be conducting live polls that will automatically appear on your screens. Feel free to use the Q&A code references on the slides to direct you to the relevant websites relating to the topic being presented today. We will do our best to answer as many of your questions as we can during the webinar. However, we receive a large volume of questions and we may not have time to answer your questions during the webinar. After this webinar, we will collate all the unanswered questions and will provide an answer to as many of these as possible. A copy of the questions and answers will be sent out in the weeks following the webinar. Now, without further ado, it's over to you, Nath. Take it away.
Thank you, Gotze. Welcome everyone, and thank you for joining us today. In this edition of the Practitioner Education Series, we will share with you just some of the common non-compliances our team is identifying across all stages of building works. The purpose of sharing this information is to help in the prevention or even the early detection of non-compliant building work. As we're all aware, the cost of building is ever increasing. One of the key reasons for this is non-compliant building work. Non-compliances compound these overall costs due to rectification work required in both design and labour. This results in lengthy delays and having to work backwards towards compliance. Please note that this presentation focuses on the common non-compliances of building only, not plumbing. In sharing the common non-compliances we are seeing, we will also be discussing exactly what is compromised by the non-compliance, the impacts of the non-compliance, the best ways to avoid the non-compliance, and just some examples of rectification of non-compliant building work, just to help illustrate the rationale in that respective building code requirement. In today's webinar, we'll cover the following: an introduction to the Proactive Inspection Program, otherwise known as PIP, discussing the risk matrix our team used for each inspection. We will then discuss just some of the common and critical non-compliances we are seeing across all stages of building work, such as slab reinforcement and concrete cover, holes in framing, fire separation, and water stops at wet areas. First off, a quick introduction or a reintroduction for some to the Proactive Inspections Program, otherwise known as PIP. A quick refresher for those of you who are not familiar with the Proactive Inspections Program. This program was launched back in 2015 to provide a health check on active building work within Victoria, identifying which areas our industry is excelling in and which areas are not meeting legislative and community standards. Sites are selected based on building permit information entered into BAMs. Criteria such as building classification, building size, type of building, date of permit issue, are some of the key factors used. The selection process deliberately excludes practitioner details, and it does feature some degree of randomness. We aim to visit a range of building types across various stages, and we are fortunate to have the capabilities of inspecting building work outside of the mandatory inspection stages. The primary reasons we consider this beneficial is, firstly, it allows for the early detection of non-compliances or oversights, which would likely result in earlier commencement of rectification work. Examples of this may be siding issues, damaged framing, incorrect installation of slab reinforcement. And secondly, it allows for the ability to check critical building work that does not form part of a mandatory inspection and is often self-certified. Examples of this include the installation of fire separation walls or party walls, and waterproofing, including suitable substrates. On the bottom left corner of your screen, we've included a QR code. If you'd like further information on the program and its findings, please feel free to scan the QR code and it'll directly to this information. It'll direct you to that information rather. Acknowledging that we are the Victorian Building Authority, post-COVID, the VBA have increased again their capacity to conduct inspections in regional Victoria to ensure we are able to assist stakeholders statewide deliver better and safer buildings. With initiatives such as the Build a Web program, we anticipate an even greater reach across Victoria over the next 12 months. It's becoming the norm for regional practitioners to have engagement with our field staff in regional Victoria. Again, we've included a QR code at the bottom left corner of the screen, which will take you to further information about the Proactive Inspections program. Now, understanding our risk matrix. Each inspection conducted is assigned a risk level depending on the risks observed at the time of inspections. There are one of 4 possible outcomes for each inspection. The first is a low risk pass. This indicates that no risk has been identified at the time of inspection and there are no apparent oversights in compliance. The second is a low risk. This indicates a risk has been identified. However, we believe that the oversight in this risk will not cause significant harm to the project as it progresses and there is ample opportunity for rectification. The third is a medium risk. This means a risk has been identified that, if left untreated, would cause an adverse effect on the performance of the building or compromise safety to the community. These are risks that are an oversight which should be attended to as soon as possible. And lastly, we have a high risk. This means that a risk has been identified that appears to be a significant oversight and provides an imminent risk to the building or the community. In cases such as this, urgent attention is required to rectify the matter and the VBA will request a response within 7 days. The total number of inspections conducted and assigned risk levels are also shown at the bottom of your screen. We can see that around 48%, or just under half of our inspections conducted, have resulted in either medium or high risks being identified. We are fortunate to be able to identify these risks. However, we must also take this data and feed it back to the industry to help prevent them from reoccurring, which is the purpose of today's presentation. I'm now going to run through a handful of defects which we're frequently seeing across various stages of building work We believe that shining a light on these defects and how they can be avoided will help reduce them from occurring. Consequently, we hope this will result in safer buildings as well as reduce the time and cost of building projects. Moving into the technical side of things, we'll start things off with slab reinforcement and concrete cover. What is concrete cover? Concrete cover is the thickness of concrete between the slab reinforcement and the edge of the slab, whether that be top, side, or ground. The two key purposes of having adequate concrete cover are, firstly, it ensures that the reinforcement is protected from the elements, safeguarding it from corrosion. In other words, the concrete acts as a shield for the steel. And secondly, the steel remains well anchored within the slab, distributing and transferring loads effectively, allowing it to perform its best structurally. The end result of inadequate cover is a weaker slab. The two photos shown are examples of incorrect installation of slab reinforcement that subsequently result in inadequate concrete cover. In the bottom photo, we can see that the entry bars appear to finish above the top of the formwork, which you can see in the background. Not only does this not achieve the minimum required concrete cover of 20 mil to the top of the slab, as per AS 2870, in this case, the re-entry bars will likely protrude through the top of the finished slab. Scenarios like this are a prime example of why structural engineers will always nominate the re-entry bars to be tied to the underside of the slab fabric. In the top photo, we can see that the slab mesh is quite close to the formwork. AS 2870 requires a minimum of 40 mil cover to the external edge of the slab, so we want to see a 40 mil gap between the end of the slab fabric and the formwork. The slab mesh shown is clearly within that 40 mil and possibly touching the formwork. This would likely result in the slab mesh being exposed to the external elements after the concrete pour and then corrosion spreading through that slab reinforcement. Additionally, if the steel is too close to the formwork, it will be difficult to pour concrete through these areas and may result in honeycombing of the concrete, which I'll touch on again shortly. The easiest and cheapest way to avoid issues relating to insufficient concrete cover is to ensure that the steel is installed correctly prior to the slab being poured. The installation of even the most simplest of materials, the humble bar chair, plays a crucial part in ensuring that we achieve adequate concrete cover. The NCC requires the spacing of bar chairs to not exceed 800 mil, as well as steel to be supported off the ground or void formers or waffle pods. In the top photo, we can see that while some may argue that the chair spacings do not exceed 800 mil, that steel is clearly not adequately supported and is in direct contact with the waffle pods. In the bottom photo, we can see that while the steel reinforcement appears to be supported adequately in terms of being supported off the void formers, the chair spacing is greater than 800 mil. This results in additional load on the bar chairs, which may result in those bar chairs sinking into the void formers. Thus, the steel would then be not adequately supported. In this slide, I've also included the requirements for the concrete mix itself for the slab pour. The reason I've done this is, amongst other things, it also impacts whether or not adequate cover will be achieved. Let's have a look at why. In the photo on the left, we can see what is called honeycombing of the slab, otherwise known as popcorning. Honeycombing is a defect caused during the pouring of the slab. It may be due to insufficient vibration of the concrete during the pour, not allowing the concrete mix to fully settle through the slab. It may be due to inadequate concrete mix, or due to the steel being too close to the formwork, preventing concrete from evenly settling through those spaces. The reason this is defective is that the shield, which is the concrete cover, does now not fully protect the slab reinforcement and leaves it more exposed to the elements and not fully anchored within the slab. On the right, you can see exposed slab reinforcement that is beginning to show signs of corrosion. This is a direct result of incorrect installation of slab reinforcement. Whilst this is defective, there are avenues to rectify this to make it compliant, and the earlier the detection, the better. In both scenarios, you would need to consult with your design engineer to obtain a rectification detail, instructing how to address the defective work. Please note that this detail would also need to be approved by your relevant building surveyor. Rectification works will likely involve cutting back part of the slab, treating the slab reinforcement, applying specially formulated products, and then rectifying the concrete finish. As you could imagine, the costs and time involved in obtaining rectification from your engineer, approval from your RBS, engaging a contractor to undertake those works, getting all the materials that you need, and then getting a re-inspection, those costs would be significantly greater than just getting the initial installation correct. The photos shown are example only, and you would need to engage a design engineer and building surveyor for formal direction. Another common oversight we're identifying at slab reinforcement stage is the lack of additional steel installed where services penetrate the slab. Of course, having to cut steel to allow for a service penetration is unavoidable. However, whenever slab reinforcement is cut, that structural element is immediately weakened and reinforcement must be installed. Additional reinforcement must be installed to restore that strength. In the photo shown, we have two examples. The first one on the left shows slab mesh being cut to allow for a service peno. The second photo shows an edge beam where the trench mesh has been cut to allow for a service penetration. As you can imagine, the cutting of a continuous steel bar immediately compromises the strength of that reinforcement across that section. We can see in these photos that no additional steel has been installed at either of these sections. Although we know that cutting steel requires additional steel as per AS 2870, it is important to note that rectification works must always be designed by the structural engineer. In most cases, a detail will be included in the structural drawings for that project, and we simply cannot decide for ourselves what the appropriate amount of additional steel that required is. You must always consult your structural engineer. Here we see two examples of rectification work for when steel reinforcement is cut to allow for services. I must strongly reiterate that these are examples only, and you must only carry out rectification works that are designed by the structural engineer for that project and approved by your RBS. On the left, we have a detail for a waffle slab where the internal rib reinforcement has been cut to allow for a service pipe. The structural engineer in this case requires, firstly, the void former of the waffle pod to be cut back so as at least 100 mm clear from the service pipe. And B, or secondly, it requires an additional bar installed on each side of that penetration with nominated lapping requirements. Put simply, we've cut one bar, so the engineer has asked us to install an extra 2 bars to restore that strength. On the right, we have a detail for where the slab fabric is cut to allow for a service pipe. In this case, the structural engineer requires 4 N12 bars that are at least 1200 mm long and run in each direction around that pipe. If ever you are presented with a detail that does not include enough information for you to be sure that you are compliant, always contact the structural engineer for advice and do not make assumptions. If ever you observe slab reinforcement to be cut to allow for services, always check that additional steel has been installed and that the additional steel is in accordance with the design engineer's detail. Now, we'll be doing a few pop quizzes throughout today. The first quiz for today is, what problems may be a direct result of inadequate concrete cover? Is it A, corrosion of reinforcement, B, poor anchoring of reinforcement, C, reduced slab strength, or D, all of the above? For those that select D, you are correct. It is all of the above. Moving on from the slab and onto the frame, particularly holes in frames. Penetrations to frames are a common occurrence that, again, are almost always unavoidable. It is important to highlight that cutting any hole or notchings into the timber frame, namely load-bearing walls and braced non-load-bearing walls, have adverse structural effects that will weaken the frame. Often, penetrations or cuts to the frame are made after the mandatory frame inspection, meaning that the building surveyor who oversees the entire project and the building inspector who did the frame inspection are not aware that these holes have occurred, which means that these alterations to the frame are not checked for compliance. There are many timber frame elements which may be compromised by rough-ins for services, elements such as studs, floor truss strongbacks, floor beams. However, for today's presentation, we're only looking at top and bottom plates. AS 684 allows for a maximum of a hole of 25 mm diameter to top or bottom plates of load-bearing or brace wall. Anything greater than a 25 mm diameter will result in the frame's loading or bracing capacity being compromised. Holes larger than this 25 mm require rectification to restore that strength. In the first photo on the left, we can see that the bottom plate is discontinuous to allow for a plumbing penetration. Now, although this is unavoidable, it still must be rectified to restore that wall frame strength and stiffen that bottom plate. AS 1684 does not allow for discontinuous bottom plates in any load-bearing or braced wall. In the second and third photos, we can see that the holes have been drilled to fit through surfaces. Clearly, these holes exceed 25 mm, therefore they do not comply with the minimum standard, and rectification is required to restore the strength of those top and bottom plates. In terms of rectification, you should always contact your structural engineer when cuts to the frame have been made. But for today, I'll show you how similar scenarios have been rectified to restore strength of the frame. Reiterating that any cuts to the frame which exceed the parameters of 1684 must be designed by the structural engineer. Here we're looking at just some examples of works designed by a structural engineer for scenarios where holes or cuts exceed 25 mm. In the first example on the left, we have a rectification detail where a bottom plate has been cut and is discontinuous. To restore the strength of the bottom plate, in this case, the structural engineer has nominated a fixing to either side of the penetration. It is stipulated that in this case, again, the detail is only applicable if the opening is a maximum of 250 mm. If on site the opening exceeds 250 mm, you would need to go back to your structural engineer for further advice. In the second and third example, we can see proprietary products designed to stiffen the top plate. Now, these proprietary products are fantastic and they're very easy to install. However, they still have their own important and strict installation requirements, which must be complied with as per the manufacturer's respective requirements. Some of the examples of these strict requirements are some stiffening plates must be installed hard up to the stud, meaning that the hole must be pre-drilled at a specific distance from the stud. Some of these plates must be installed prior to running the pipe through. They cannot be retrofitted. In some cases, or most cases, you can't have more than one per stud bay, and they cannot be used in consecutive stud bays. And also, they're not to be used in bays or stud bays where there are high loads, such as a girder truss or a point load block from an above floor. Now, these design limitations are only brief examples of compliance for these proprietary products. And I cannot stress enough that the mentality of drilling holes into your frame and relying on these products to rectify the issue is not appropriate. Consideration must still be given to the installation requirements of those chosen products prior to cutting or drilling that frame. Again, consult your structural engineer prior to determine the most suitable rectification method. For those of you who haven't seen it or would appreciate a refresher, I strongly recommend viewing our previous Practitioner Education Series episode on common timber frame defects. A QR code is shown in the bottom left corner of the screen, and it's definitely worth your time if you wish to learn more or have a quick refresher on common frame defects we're still seeing today. Now moving on from the frame onto fire separation. Here, we're going to focus on a particular aspect of fire separation, the fire separation at cantilevered walls. In modern development, cantilevers are becoming the norm in building design. However, this results in additional consideration in maintaining fire separation between the adjoining dwellings. Maintaining the required FRL, or the fire resistance level, must always be taken into consideration. This means ensuring that none of the following are compromised. Firstly, the structural adequacy. Can the fire separating wall or the party wall maintain its stability and load-bearing capacity in the event of a fire? Integrity. Can the fire separating wall resist the transfer of flames, smoke, and hot gases from one part to another? And third, the insulation. Can the fire separating wall contain temperatures and stop heat transferring from one part to another? The two elements I want to focus on today when discussing a cantilevered fire separating wall is the structural adequacy component and the insulation component. When checking a cantilevered party wall, there are two important things to consider, as well as the overall installation of the party wall. Those two things are, firstly, if either of the two dwellings burn to the ground, will the party wall remain standing? And secondly, are there avenues for heat to transfer via the supports to the adjoining dwelling? If the answer is yes to either of these two questions, then the FRL has been compromised. In the first photo, on the left, we can see an example of a multi-unit development where a cantilevered first floor occurs, something which I'm sure most of you have seen. Now, the next two photos are examples of incorrect supports, and I must clarify that these example photos are not taken from the same site as the design example. The middle photo, the incorrect support photo, shows that steel support plates have been installed to support that fire-rated wall. Now, these supports appear to be structurally sound. However, we can see that the support plates are welded to both steel beams on each side. By doing so, this creates a pathway for heat to travel from one dwelling to another, therefore breaching the insulation requirement of the FRL. In the third photo, we can see somewhat of a miracle, where a sharp liner party wall is wholly suspended at the cantilever with no supports. In this case, the wall was held up with aluminium clips, and these clips are designed to melt away in the event of a fire. If this were to occur, the cantilevered section of the wall would come crashing down, allowing fire to spread freely to the adjoining dwelling. Focusing on the support components only, here we have two different details from two different manufacturers, one from CBMA being the section detail on the left, and one from Hebel being the plan detail on the right, where they provide construction details showing how to support their respective party wall while still maintaining the required FRL. Now, these are examples only just to help illustrate the rationale in supporting a cantilevered party wall with respect to the required FRL. I must also clarify that the floor beams and support plates must be designed by the structural engineer, as there are many variances that would dictate these elements, such as your building height, your wall height, your roof type, etc. If you look at the plan view detail on the right, we can see that the support plates are staggered, meaning they are fixed to alternating sides of the party wall. Each plate is fixed to one dwelling only, meaning heat will not transfer from one dwelling to another. This sees compliance with the insulation requirement of the FRL. As those support plates are staggered and designed by the engineer, but as they are staggered and fixed in the alternating sides, this means that should one dwelling hypothetically burn to the ground, the building left standing would still be able to structurally support that party wall and continue to be protected from the spread of fire. This sees compliance with the structural adequacy requirement of the FRL. Now, there's also additional requirements that we can see, such as packing the underside gaps with fire-rated rock wool. I also note that the type of ceiling plasterboard installed underneath the cantilever must be designed by your relevant building surveyor, depending on the type of construction, say the building type or the building classification. If your project has a cantilevered party wall, please ensure that you refer to the respective manufacturer's installation guide and ensure that the structural engineer has designed his floor beams and support plates with respect to that nominated fire separation system. Just to reinforce the rationale to consider when observing a cantilevered party wall, ask yourself, if either side burns to the ground, will that party wall remain standing? And secondly, is there a path of travel for heat to get from one dwelling to another? If the answer is yes to either of these, you can guarantee there is non-compliance that must be addressed as soon as possible. Staying on party walls, but moving on to the aluminium wall clip component. Now, these clips are installed for the purpose of holding the party wall in place by being fixed to both the dwelling frame and the party wall. They have to be installed on both sides of the party wall. Now, the Goldilocks theory does apply to the installation of these clips. And when I say that, I mean that it is possible to have too many clips and it's possible to have too few clips. The installation has to be just right and in accordance with the respective manufacturer's installation guide. If too few are installed, this means the party wall is not adequately supported and therefore does not achieve the required structural adequacy rating of the FRL. These clips are designed to melt in the heat of the fire. So again, we need to ask ourselves, if one side burns to the ground, will the fire separating wall remain standing? If less than the required clips specified by the manufacturer are installed, we cannot be satisfied that the party wall will remain standing, and therefore the risk of fire spreading to the adjoining dwelling is increased. Each manufacturer will have their own specification for fixing requirements of these aluminium brackets. For example, some require fixings along the top and bottom plate only and at nominated spacings. Some may permit fixings to studs if they're within, say, 20 millimeters of the top or the bottom plate. If you're using a shaft liner product, these clips must be installed to the H studs only. And if you're using Hebel, for example, those clips must be fixed within the center 50 millimeter line of each panel. As always, refer to your manufacturer's installation guide for detailed instructions on compliant installation. And please note that although some manufacturers' products may seem similar, each system has their own variances that must be adhered to maintain compliance with their tested product. Please do not make assumptions on similar based products. Now that we know how to ensure we have enough clips, let's discuss the issue of having too many clips. By connecting our dwelling walls to the party walls, we must also consider the acoustic impacts from dwelling to dwelling. By installing these fixings, we are effectively installing sound bridges for these sound waves to travel from one dwelling to another. The NCC has a requirement to ensure sound insulation is maintained between dwellings, and each accredited fire separating system must also comply with the NCC's acoustic requirements. The way that the sound insulation component is addressed is by ensuring that the aluminium wall clips are not excessively installed so as to not provide too many sound wave bridges between dwellings. It's kind of like a balancing act in maintaining both the structural adequacy of the party wall and the sound insulation requirements of the NCC. Generally, aluminium wall clips cannot be installed along noggins or the mid-height of walls. However, there are some scenarios where the mid-height clips are permitted. These scenarios are triggered by usually the wall height. These scenarios also have strict requirements on the spacing of these intermediate clips. For example, where a manufacturer may require intermediate clips along the wall, they may also require those intermediate clips to be no closer than, say, 1200 mil, and will also specify the consideration to discontinuous construction is required. This means considering the room type on either side of that party wall. If ever it is observed that the aluminium clips are installed to areas not along the top and bottom plate, please ensure you refer to the relevant installation guide for that system and ensure that the acoustic requirements of that system are still adhered to. Also, for those of you who haven't seen it or would like a refresher, we also have a previous Practitioner Education Series episode on common fire-rated wall defects. A link is in the bottom left corner of your screen if you wish to learn more about that. Fire-rated walls do not yet form part of a freestanding mandatory inspection, so the more we can educate everyone on the correct installation of these crucial building elements, the safer we and our buildings will be. Second quiz for the day. This one's a little bit trickier. Now, ignoring all the floor truss non-compliances and focusing only on the cantilevered party wall, does this cantilevered party wall appear to be compliant? The answer is no, it does not. Firstly, while the steel supports appear to be solid, it is fixed to one side only. So if the dwelling on the left were to burn to the ground, that fire separating wall would come down with it. Also, we can see what appears to be a timber ledge sitting above that support. Obviously, timber is a combustible material and therefore would also contribute to the spread of fire. The final topic I'd like to discuss today is water stops and preventing water from escaping wet areas. A common and crucial non-compliance we're continuing to see is the way water stops are being installed in wet areas, particularly at cavity sliders. For those of you who aren't familiar with this building material, a water stop is an L-shaped metal angle that is designed to retain water and keep it within the wet area. It's important to note that the water stop must work in conjunction with the waterproof membrane. Only when installed together and correctly, only then will the waterproofing system perform well in keeping water within that wet area. In this slide, we're looking at wet areas where the tiled area terminates at the cavity slider, a very, very common occurrence in today's buildings. As you can see, the water stop terminates inside the cavity and there is no consideration to keeping water within that wet area. What will inevitably occur in this scenario is that water will travel along the subsurface and escape via this opening. Once this has occurred, the water will then come into contact with your timber frame, your carpet, floorboards, architraves, skirting boards, etc. Your timber materials will begin to swell and you'll likely get mold occurring there very quickly. Now imagine having a shallow bowl and drilling a hole in the bottom corner of that bowl, then trying to fill that bowl with water. It'd be impossible to maintain any water retention in that bowl. The same principle is occurring here in these photos, where the water is effectively funneled into that cavity. Let's have a look at how this can be waterproofed correctly. Here we have a detail taken from AS 3740, as well as a photo from an applicable scenario where we can see how compliance is achieved. We can see that the water stop is waterproofed and connected to the perimeter flashing, which runs around the wet area like a mini retaining wall for the water. This creates a fishbowl that compartmentalizes the wet area and ensures the subsurface water does not escape that wet area. Within the cavity, this is done by creating a return junction with the water stop. The detail shows that the bottom leg of the water stop is cut. The water stop is then folded 90 degrees. And that water stop return then joins up with the perimeter flashing to form that continuous barrier. If this is done incorrectly and identified after the tiles have been installed, rectification works would likely involve removing tiles, most likely destroying the waterproofing membrane as you're doing so, installing that waterproof junction, that water stop junction rather, reapplying your waterproof membrane, rectifying any damage you've caused along the way, and then reinstalling your tiles on top. As you can imagine, this will incur time and labour costs and frustrate every stakeholder involved. When observing a water stop at the entry to a wet area, whether it be a cavity slider or a regular opening, ask yourself, does the water stop connect to the perimeter flashing? And are there openings for the subsurface water to escape that wet area? As we all know, it only takes the smallest of openings for water to begin getting into places we don't want it to get to. And also, for those of you who haven't seen it or would like a refresher, I strongly recommend viewing our recent webinar on AS 3740, which discusses the waterproofing of wet areas and also run through the changes from the 2012 standard to the 2021 standard. It's definitely worth your time. The QR code is in the bottom right. Now, final pop quiz for the day. Having a look at the photo provided, can you determine if the water stop and the perimeter flashing at the entry to this wet area is compliant? The answer is no, it is not. Not only is there a clear gap at the end of the water stop, there is also no evidence of a waterproof membrane forming part of that perimeter flashing. Water will escape through that gap and also be absorbed by the timber frame. Wrapping up the topics we've touched on today, we've learned about the purpose of concrete cover, the consequences of cutting slab reinforcement, the impacts of drilling holes into frames, how to ensure the FRL is maintained in a fire separating wall, consideration to sound insulation, particularly at party walls, and ensuring water is kept within wet areas. In providing an insight to these common non-compliances we are seeing, we hope that this will help in the prevention or even the early detection of non-compliances. By understanding the rationale behind why something is not compliant and the impacts of that non-compliance, this allows us to exercise better judgment when observing building work. The more we understand the principles behind our building code requirements, the safer and the better our buildings will be.
Thanks, Nate, for the presentation. There was a lot of great info in there and also lots of activity in the chat, which was great to see. As Nathan mentioned, we strongly encourage you all to view the previous webinars done by the building proactive team on common framing defects and fire-rated walls. Building awareness to these common issues the team identifies will hopefully result in better outcomes moving forward and avoid costly rectification works in the future if the non-compliance remained undetected. Thank you to everyone who took the time to submit their questions. It was greatly appreciated. The team will continue to answer as many questions as possible while we are still presenting. Just another reminder that if we haven't answered your questions, our team is still working through it and you'll receive your answers in the next few weeks along with a copy of all the questions and answers from today's session. Now let's move on to the pre-submitted questions that we received during the registration process. Let's go to question 1. Can you please clarify what is the minimum required concrete cover for a dwelling? Slabs.
Yeah, sure. It's noted in both the NCC and AS 2870. We've got 40 mil to unprotected ground. So unprotected ground would be a footing that's not protected by a membrane, so your strip footing or a slab that doesn't require your black poly. 40 mil to your external exposure, so your edge of the slab. 30 mil to a member in contact with the ground, so that if you got your black poly membrane or a waffle pod, and 20 millimeters to an internal surface. So, for example, being the top of the top of a dwelling slab.
Question number 2: why are slabs poured if the reinforcement is not correct?
Yeah, good question. The short answer is a slab. It shouldn't be poured unless that slab reinforcement is approved at the mandatory inspection, and that mandatory inspection can't be approved unless all elements are compliant. The best way to assess compliance of slab reinforcement is to make sure all steelwork is completed prior to the inspection. This means all your boxing, your formwork, all your steel is chaired and tied. This will allow the inspector to conduct their inspection properly and identify exactly what the oversights are. If you conduct an inspection on works that are less than 100% complete, it's definitely not appropriate, and that's kind of where the wheels on the compliance cart begin to wobble.
Great work, mate. Question 3: what is the best way to avoid framing defects?
There's a bit to unpack there, and I saw a couple of questions in the live chat as well that came up about this. What we are finding with our frame inspections is there's 2 stages of frame completion. The first one being once the frame is ready for your mandatory inspection, and the second being once the plaster is ready to be installed. The reason there's such a difference is because during that timeline between your mandatory frame inspection and the installation of plaster, that's when all your rough-ins for services get installed. This means your electrical work, your plumbing work, your air cons, they have to run their pipes and cables through for obvious reasons, and holes need to be drilled into that frame. So probably getting back to the question, I can best answer it in 2 parts. For the mandatory frame inspection, much the same as what we discussed for the slab steel, ensure the frame rather is completed and ready for inspection. If the frame isn't 100% ready for inspection, it's not appropriate to conduct your mandatory frame inspection at that stage. And the second part is, after the mandatory frame has been approved, if and when any alterations to the frame are made, consideration needs to be made to every hole and notching made to that frame. You should always ask the question if you're unsure. If you start adopting the mentality of she'll be right when drilling into the frame, that's kind of where structural compliance really starts to go downhill.
Question 4, why are waterproofing defects still occurring?
Again, a fair bit to unpack with that. Answering it purely from a proactive inspections point of view, what we're finding is that when we discuss compliance items on site, often that tradesperson, they're unaware that they are doing those works incorrectly. They think they're completing the task, probably because that's the way they've been trained to do it. So this kind of comes back to training and education. For the most part, people don't want to install things incorrectly. People want to do a good job. So raising issues in forums like today and discussing them on site with the tradespeople is a great way to curb incorrect installation. And also probably want to point out that while waterproofing doesn't yet form part of a mandatory inspection, in the latest 2021 edition of AS 3740, there is a clause that requires a visual inspection to be conducted of that waterproof membrane prior to installing any of your tiles or your vinyl. It's much easier to identify and repair any incomplete or defective membrane prior to installing the tiles. So I strongly recommend treating this inspection with the utmost importance moving forward.
Question 5, at which stage of the building do the proactive inspections team aim to do their inspections?
Yes, it's a very good question. We do understand, because we have the ability to conduct our inspections outside of the mandatory inspection stages, we should utilise this where possible. We don't want these inspections to be another mandatory inspection. Myself personally, I prefer to conduct these PIP inspections at stages such as post-roughing, so a frame, post-roughing frame or pre-plaster, fire rated wall stage, and even checking waterproofing as well, including your substrates. Purely because these inspections don't form part of a mandatory inspection and they're not checked for compliance formally. Because our sites are selected at random, we can't always time these inspections to get to these critical stages. That doesn't mean that there aren't stages across the board that aren't valuable. There's value in inspecting sites when it's only at excavation stage, because we're still getting issues such as protection works or even slab footings not being founded adequately. There's definitely value in inspecting works when they're at final stage. We're still consistently seeing defects relating to smoke alarms, bowel compliance, and stair issues. Yeah, regardless of what stage it's at, it's always good to get another trained set of eyes over the job to look out for any defects that may be an oversight from the builder, site supervisor, drafty, inspector, RBS. It's always good to get another set of trained eyes over it.
Question 6, does the proactive program also focus on commercial buildings?
100%, yes. We do have a team of inspectors dedicated to your class 2 to 9 buildings. Taking you behind the scenes a little bit, today's webinar was originally planned to share common defects of both residential and commercial buildings. However, with only 1 hour allotted to these webinars, we quickly learned that there's just far too much content to respectfully discuss in 1 hour if we included commercial. Just like in residential inspections, there's a broad range of common non-compliances found in commercial buildings, such as fire safety, damp and weatherproofing, disability access, structural defects, exit emergency lighting, warning systems. But to everyone watching, if you would like to see a freestanding practitioner education series episode on common non-compliances for commercial buildings, or even if there's another topic you think would be a great freestanding episode, such as slab reinforcement or masonry, please do let us know in the feedback form. We want to try and tailor our content to meet the demand as best as possible.
Brilliant. Thanks for that, Nathan. Thanks for the detailed answers.
Welcome.
And thanks everybody for joining us today. We hope you have enjoyed the session. Just a reminder, we will collate all your unanswered questions and we will answer as many of these as possible and send you the answers in the coming weeks. We will soon be sending out an email that includes a webinar survey, as well as proof of attendance and links to today's webinar and slideshows. To find out about when the next Practitioner Education Series webinar will be, please visit our website in the coming days and keep an eye out for our emails. Thank you all and enjoy the rest of your afternoon.